So we're going to talk about beam shear and moment. Beam shear is basically the perpendicular force applied to a beam. So if let's say this is a beam, the shear would be this downward, or maybe upward is possible, but naturally it would be a downward force which is perpendicular to the beam, and then beam moment would be the rotational force that the beam will be experiencing. And then next we would be talking about the supports. We have the usual hinge and fixed, and also the roller. These are the common types of supports that we will be using. There will also be rocker, but we haven't discussed that in school, and link, so I'm not going to be including that. And then there are different types of beam, which we will only be talking about a cantilever beam, which obviously uses a fixed type support. And then there will be a simply supported beam. It would look something like this. And then finally, the third one would be an overhanging beam. It would be something like this. Maybe this, I don't know, I'm not sure. But the point is, there is something overhanging. I feel like that's the point. There is also a continuous beam, which is basically a beam with a lot of supports, which is continuously placed within that beam. So to review, this is beam shear, this is beam moment. Beam shear is the beam experiencing perpendicular force, while moment is the beam experiencing a rotational force. I do not know anything to further expound that, but that's the main idea. And these are the common types of support, common supports, and then lastly the types of beams that we'll be using. Next, we'll also be talking about how to draw the shear and moment diagram. So it's simply like this. It's a table where this first box, I guess, is referring to the type of load, and this will be the shear and the moment. So in point types of load, or point load, the shear will be drawn as a horizontal straight line, while the point load of the moment of a point load would be an inclined kind of diagram. This is horizontal and this is inclined. After that, there is something called a uniform load, which is a distributed force, except that it is in a uniform state, all equally distributed. The load is equally distributed, and the shear will be drawn as inclined, while the moment will now be parabolic. Something like that. This is inclined and this is parabolic. And then lastly, a varying load, which is a distributed force with a varied amount of load. It will have a shear diagram of a of a parabolic drawing, like this. This is parabolic. And then for the moment of a varying load, it will still be a parabolic figure. As you can see, there is a pattern. It will start as horizontal and then inclined and then parabolic, and then this would be a third degree parabolic figure, I guess. That is all.